I'm Tom. I'm the VFX tutor here at Escape Studios, and we're going to be doing a little webinar into UVs in Unreal, what they are, how we can use them, and how we can make some cool effects with them. So firstly, a bit of admin. Everything we're going to be doing today, hopefully if you're watching now, you can follow along, but if you're watching later on, it's going to be a tutorial that I have on my website. So if you go to thalvfx.com and then go to the tutorial index, have a look. I've got quite a few different tutorials for the material editor and blueprints, and we're doing this one here, UV tricks. You can download the project files, and I'll just stick a link in the chat. So if you can get these files and follow along at home. Right, so when we open it up, we've got these 4 materials pre-made. That corresponds to the 4 tutorial series, and we're going to be doing, like I say, the UV tricks one. So if we just open that one up, what do we have? Well, this is the UV node in Unreal. Well, before that, what actually are UVs? If we just go to the internet quickly and have a look at a UV map. Hopefully you've all encountered UVs before. We're going to be looking at this from a sort of effects point of view, but this is a character. So what UVs are here are a way of encoding that 3D shape and that 3D character into a 2D layout, so we can paint it. So if you wanted to paint the character's face, you can make that out down here. Obviously that maps up here, and the hands, other bit of recognizable things. Brilliant, works perfectly. With VFX though, quite often you want to do slightly more complex things with your shader, doing sort of scrolling noises, those kinds of things. And so we can use our UVs to help that and kind of work with that. So let's jump back over into Unreal. This is the UV node in Unreal. So if you hold U and click on the keyboard, it brings it up. It's also called a text chord or texture coordinate. Same kind of thing. And I've just plugged it into the emissive. So I'm just visualizing what this node is doing. And I'm going to check to the plane. Everything disappears because it's backwards. We just have to turn that around, and then we can see our plane. So what do we actually see here? Well, there's blacks, and then reds and greens and yellows. Unreal is displaying this as color, but actually all it is data. And if I open this up and just mask out the red channel, so this node here just takes that input data and just discards all the data that isn't in the red channel, we can see it's a gradient. So we have values of black over here, and then over to white on the other side, and to say the same with the green. If I open these guys up, connect this into the emissive color, it's actually just 2 gradients. So for the sake of completeness, we'll try it with the blue. What will happen if I connect him? Gives us an error. There's actually no blue data in here. So the type of data that a UV coordinate is a float 2. It says it here, float 2. There's 2 channels of data being there, so you'll hopefully be familiar with color and RGB. So I bring in a texture. Here we've got red, green, and blue channels individually, and RGB is 3 channels altogether. Well, with the UV, it's actually 2 channels together, the red and the green. So if you plug this one back in, we're getting this gradient, like I say. And then if we have a look at this guy, if we think about it, every single pixel on this square has a unique set of 2 coordinates. So the top up here, top left, that's black, black, 0, 0. Down here, white, 1, 1. So what we're having here is a unique unwrap of every single, or a unique coordinate of every pixel on this square, which we can then use with our textures. So just moving down, connect this back up. So just for completeness sake, if we're masking out our individual channels, how do we combine them back in? We use the append node. So this takes those 2 channels of data, red and green, and just brings them back into a UV coordinate for us. So yeah, our UVs plug into the UVs of a texture sample. I plug this into the emissive color. Nothing's happening. By default, Unreal is really helpful for you. It assumes all the default things for you if you don't plug anything in to your UVs. But if you want to edit it, you need to have access to that node, and we can do things in here to give us some maths. And what's happening is everything in this top corner, this 0, 0, that's corresponding to this pixel here, and then correspondingly across and down and up, and so we get our map. Next example looks quite similar, right? This here looks very similar to this. We're getting the same red and green values, but if I connect this up, all goes horribly wrong. Oh no, what's happened? This is actually a texture sample. So if I open up the actual texture in Unreal, it's the same thing. We've got our red channel and our green channel, and we've got a gradient in red and a gradient in green. But I've made this in Photoshop, and then when I've imported it, obviously Unreal tries to compress things down, makes less space on disk, and you get compression errors. So you can see maybe you get a little bit of banding, especially here in this green, in this red channel. And that's not much good for us for using UVs. You can do different compression settings and things, but why is that useful? Well, if you do want to use a gradient in your material, let's say you're making a light shaft or something like that, and you want to fade off that light over the course of the mesh, you can use these gradients just as maths. Mask out one of the channels, and then just use that. And in fact, if you right click and have a look at one of the material functions that Epic have provided and included with Unreal, there's one called linear gradient, and you get a U gradient, emissive color, there it is, and a V gradient. Well, what's this doing? It's always a good idea when you're using material functions, just double click, open them up, have a look inside. There it is, texture coordinate, masked in red, masked in green. So they're doing exactly what we've just done, and just taking that UV data and just masking out individual channels to give you your gradients. They're mathematically defined, so they're really smooth, really nice. Get a much better result than trying to do a gradient mask like this. And it uses less texture samples, so it's more optimal. So really nice. On to the next. Plug into the emissive color. Here, we've changed the tiling. So you see these values of yellow. What that's actually happening here is the values are going above 1. Unreal displaying color, it can't display a value over the 1. It doesn't start making things bloom or glow. That would be a really unfortunate thing if your material editor was glowing all over the place. So although we're only seeing really information up here, all this yellow here, there's still data there, we just can't see it. So if you plug that into our emissive color, plug that into a texture sample, you can see we're tiling. So with our character unwrap earlier, obviously this was unique texture. It was just painted once onto this model. Wouldn't be any useful if you stuck it on a wall or something, but very common in video games, tiling textures, something that's been designed to tile seamlessly. You can spread that over large floor areas, things like this, get some really nice results. And we use them all the time in effects, things like noises and stuff. Here, well, the values here that were over 1, they were still working, but actually it's only the UV data that's between 0 and 1 that's used, that's only helpful. So here we have our 4x4 tiling, and if we do this node here, which is a frac, that stands for fractional, so it only takes the decimal part of the number. Anything whole number parts just get ignored. We can see it's repeating. If I go plug that into the emissive color, so you see our 4x4 tiling, it's taking that 0 to 1 data and repeating it 4 times. If I change that to 3x3, 3x3, you can see we're now getting that 0 to 1 repeated 3 times. It's the same. I mean, if I plug this in, there's no difference here between the fract and the non-fract one. Okay, the number of tiles is different, but the visual result at the end is the same. So the engine understands to discard the whole number part. Most of the time, this won't become an issue, but if you're doing some quite complex maths with your UVs before you plug them in, sometimes you might need to frac them just to keep them back in here. But it's good to understand. It's good to know that these are just like that repeating 0 to 1 values, which gives us our tiling. And what are we doing here? We don't have to tile whole numbers. We don't have to tile equally. So here I've taken the first column of my number sheet. If I just quickly set this to 1, so we can see the texture untiled. I've taken that first column and I've plugged it in. So another little trick here. All the boxes in Unreal are actually calculators. I can type 1 divided by 8, and that will do that for me. Really helpful little tip. Yeah, I only want that first row. So I'm only going to tile this one this much, 0.125, not using the full bit. If this was scrolling or had different things on it, there's different ways we can use that. But generally with environment textures, you want them to be square, you want them to be the way you've made them, you want them to map to the character correctly. But with effects, we can be a little bit more generous, maybe a little bit more adventurous, using things in slightly more exotic ways. So there's nothing wrong with having our tiling not being square. Really nice. Cool. So moving on. What happens if we add numbers? Well, if these are all just numbers, these are numbers from 0 to 1. If I add numbers to it, here, let's zero this out again. Not adding anything, nothing happens, right? I'm adding 0. We know that doesn't do anything. If I add a little bit in my red value, see I'm starting to offset things. I'm starting to move them around. Looks like the texture's moving. It's actually the UVs underneath the texture that's doing the moving. And then we can kind of arrange our tiling. If you want a tiling texture to sit nicely into the wall, you can adjust it here. And again, if you add it in green, you'll be moving them up and down, and red will be X, left and right. Very useful. Comes up occasionally. Well, so far everything's been static. What about if we want to have some animation? We can add time. So here I've just taken the time node. This counts up as the engine's running. So every second this goes up by 1. And we're adding those to our UVs and we're getting motion. So again, it looks like the texture's animated, but actually it's the UVs underneath the texture that's doing the animation. And then it's just displaying this rendering. If I come here, values over 1, they don't render, right? We talked about this a minute ago. If I bring a frac node in, hopefully, we can see those UVs again back here repeating 0 to 1. Just those important values. Very nice. Create some animation. If we want, we can have controls of how fast this is going. So if we want our time to go faster, we want our animation to go faster, we multiply time by a parameter. Now, here, I'll call this something like speed. Give it a name that makes sense. Spell it correctly, helpful. 0.5. Now it's moving a little bit slower. I can slow it right down. Get really fast. So I'm just giving myself as much control as possible for how I want to build my shader. Really nice. This is great. It's got some animation. It's got some moving. Brilliant. But what about if I want only movement in one axis? This is all going to the top left, isn't it? It's always going up because we're adding values in X and we're adding values in Y. Well, if we remember right back at the start, we split our UV data into 2 channels. So we can do that. We can split it into red, do some maths over here to add time or do some distortion or whatever it is we're going to do, and then append them back together afterwards. So splitting your channels out into 2, doing all your nice effects animation work in 1, and then bringing them back. So let's have a look at an example of that. Here we are. So, like I just said, your text coordinate, masking it out into red and green, giving myself my 2 gradients, adding time only in X or only in red. Those terms are interchangeable. Red, U, X. It's all just the terminology for the first data item. And hopefully if we frac this again, bring that visibility back, we can see that our gradient is now repeating in red. When we add that to our green, green's not moving, it's not changing, so that the pixels vertically are just being wrapped the same way. Really nice scrolling texture. Unreal, ever helpful, has done this for you. So there is a node called a panner. What does it do? Well, it's got a value for speed. The defaults, I believe, are 0, 0. So whenever you create a panner, you need to say, right, which way am I panning? Am I moving left and right? Am I moving up and down? Am I moving both ways at once? Come in here, give it a speed, and then we're doing the exact same thing. So this is just adding time. So again, same as well with a texture here. If this isn't plugged in, it assumes the default values. The same with our panner. So here, effectively, time is plugged in, and the text coordinate is plugged in. So if we wanted to, we could take our text coordinate and we could tile before we pan. So anything we're doing here to the UVs, then we're getting here when we're moving them, And we could multiply our time by a parameter again. Steal this one for a second. And now I can scale down my speed, make it slower, make it really slow. Lots of control, that's what we like. We can make lots of really cool effects when we have lots of control over things. But again, it's not the texture that's moving, it's the UVs under the texture that are being added to. Sometimes understanding that kind of like can help make some nice things. What about this? What's happening here? Well, I'm using the panner again, but nothing's moving. Remember, if time is inputted, we're getting movement. But if we plug in a constant value, we can just use this as an offset. So the same way we were having here, a number, static number plugged in, and that was creating some offset to this texture. There it is. There, 0.5, we start moving across an X, 0.7. We can do the same with the panner. So here the panner has values in X, has a speed in X, so I'm moving across. My text coordinate is the same one where I've isolated a single column, and I can now, through that, use this to pick different parts of the same texture. So I might, for example, put 4 or 5 different textures, 4 or 5 different effects on one texture to save space, save memory, and then I can use the UVs of the mesh or the UVs in the material to select those. Obviously, it needs to be multiples of 8s because I've got 8 different columns in here. But really nice way. If you had like 4 different lightning bursts or something, you could use this to select one of those things at once. As well as movement, we've got rotation. I won't go into the base maths behind doing it. It's much more complicated. I also don't really know them. So we can just use the rotator, but it's doing the same thing. It's not moving the texture, it's moving the UVs. And the same, if we have our UV here and plug this in, we can see we get, if I change that to tiling, 2 by 2, that's now going to be rotating as it's tiling. And if we want to preview that nicely, we can plug this frac in. And again, not doing anything in terms of the end result, but we're now seeing those squares. And you can combine the two, you can have movement and rotating, and do some nice complex things. That's what I just did. So 2 by 2, yeah. And obviously you can go up to higher numbers, 5 by 5, whatever you need for your texture, for your effect that you're making. Awesome. So far, everything we've been doing is affecting the whole square at once. But this is just numbers. They're just 0 to 1. They're just data that we can do stuff with. So let's try that. Let's try doing some really cool things. What's happening here? Let's break it down. So I've got my panner. So I've got some movement. I'm using a texture sample. Let's have a look. So here, in the same way we were talking earlier about having UVs being red data and green data, here I've just plugged 3 different masks into the same texture. So I've got red, black and white. It's just a gradient from the center. I've got green, which is just like a circular gradient. Nice values, white in the middle, values are black at the edge. And I've got blue, load it up. It's just like an edge mask, so for fading out things over the edge. Nice texture. All I'm doing is using that green data. Let's have a look. It's that circle, that sphere mask. And what are we doing? Well, we're taking our UVs, splitting them into the red and green channel, and I'm just adding a little bit of that mask to my UVs. Notice here I'm applying by 0.15. If I just took the whole thing, I'm getting some really crazy effects. UVs are very sensitive. The values here start at 0, end at 1. If I'm adding more values that go from 0 to 1, that's quite a lot of distortion, and you can go really quite subtle with this. 0.1, you can still see there's quite a bit of movement here. 0.05. I don't know how easy that's coming across in the stream, but like really small amounts can do a lot with UVs. And very quickly, by using a slightly different texture, see now I'm not getting that bulging or that masking at the top. The whole thing appears to be moving up and down. It's almost like a flag waving in the wind, right? That could be the kind of shader you'd make just using a little bit of distortion. Not quite sure here. Mostly values of the same, and then there's a little black occasional stripe. You're getting another very different effect just by changing which of those textures we're inputting. And then if we swap over our channels so that we add the noise to the red instead of the green, we're going to get another effect, very different, very quickly. Now I'm moving things up and down, or left and right instead of up and down. So we're getting that kind of nice bulging. Looks very animated, looks very nice. It's a very powerful technique. And we're going to do another example now. So what about something that isn't quite so distinctive? Well, let's have a look at my texture here. It's just a noise. So this is, again, what they call a gray pack or a channel packed texture. It's nothing complex. It's just using 3 different channels to combine 3 different things at the same time. So simple clouds noise from Photoshop in red, a bit more high contrast noise in green, and then some sort of more puffy, cloudy noise in blue. And so taking that and adding it to our UVs, same thing, multiplying it down, again, very sensitive, and just adding a little bit in red and green, we can see, well, it's almost like an underwater effect, right? It's something very, very subtly moving those UVs, giving that distortion of light refracting. And yeah, we go really subtle, 0.05, 0.02. Really nice. And then in the panner, we're getting just some movement, just a really nice, slow, subtle movement. And we can control the distortion if we change the tiling of the noise. This tiling here is only affecting this part, and then this is still being mapped 0 to 1. You can see, if I just put that up a little bit, it's changing quite dramatically. Have the look of that, that distortion. Very cool. Bit of a problem, or potentially a bit of a problem, not always, but if we have a look at this closely, we can see these pixels here are the whiter ones, aren't they? They've been wrapped around from the other side, and the same with the red at the top. They've been pushed up and come round. If that's a tiling surface, like a big open pool, lots of water, lots of repeats of the same texture, that's not going to be a big problem. But if you're making something very specific to fit inside a certain mesh, you probably don't want that effect to be happening. We don't want that wrap to happen. So why is it happening? Well, we're adding, aren't we? So here the values were again 0 to 1, and then we're taking those values. Let me just annotate this a little bit. So here the values are from 0 to 1, and once we've added, we're from 0 plus a bit to 1 plus a bit. So we've changed what the average value is. So we've kind of moved everything up and across a little bit. Again, sometimes that's not going to be a problem. Sometimes that'll be fine. But if there is a problem, we need to know how to fix it. So let's have a look. Connect this one in. There it is fixed. How did we do it? Let's have a look. So start with our UVs, create a panner to move some movement across. So we're creating this panning noise again, and then we've subtracted 0.5. This is the key. So here the values go from 0 to 1, don't they? It's black and white values in the noise in the gray. So values of darks near blacks, whites near ones. Effectively, for every pixel we move to the left, we want to move another pixel to the right, because then, although the distortion will happen, the average of those two things will stay in the same place. So if we take that 0 to 1 and subtract 0.5, now our range here is from minus 0.5 to 0.5, right? That's basically moved that texture range, or those value ranges, down so that they're equally positive and negative. Hopefully you can see big areas of black in that preview. In the same way we couldn't preview values over 1, Unreal can't preview negative numbers. There's no way it can understand to render that to the screen. So you get this large black area. It's fine. It's just the way it renders. And again, sensitive, small amount, multiplied by 0.1. And now in our texture sample, we have a look. Every pixel that's moving across is moving up. We're still getting a wrap. We're still getting those edge pixels wrapping round, but the overall distortion is staying in exactly the same place. So sometimes you just have to do a little bit of math. It's a good way to think about things as your data ranges, just to say, well, what's my highest value? What's my lowest value? If you start adding things together, sometimes you might need to adjust them if you want to keep them kind of within that same area. Right, cool. On to something a little bit different now. Not quite UVs, but follows on nicely from this this example earlier. Well, what have I done here? Well, I'm using a panner, so I know I'm moving, and I've got a value speed and X, so I'm moving left and right. And then in my input, I've put a sine wave. Hopefully we all remember sine waves from school. Sine waves. Oh, can't spell. That's look like some Spanish. Here we are. So it's just a curve. So it just takes that input of time, and then you go up and down. So it gives you a repeating value. So again, thinking about your number ranges, here the value is going from -1 to 1. And so that sine wave plugged into this panel is just creating that left and right movement. But there's another trick here. The texture we're using, rather than wrapping around and being repeated like a tiling texture would be, it's been clamped. So the default values for this, it's hidden away here in the texture. The default values come as wrap. We just save that, go back here, and reapply this. Hasn't updated the viewport, has updated here. Just replug that in. And so we're seeing those black and white stripes moving left and right with the sine wave. And it's not a bad effect. They could do something quite cool with this. I don't know, some sort of laser grid, maybe some sort of scanning thing. But what we're actually going to do is use this as some sort of mask. I don't want the tile. I want this black pixel here to repeat forever. So all this way over here will be black, and all this way over here will be white. And there's this one transition in the middle. And the way we can do that is with our tiling. So we change this to clamp. In this case, it doesn't actually matter from the Y because it's the same, but we'll do both. And now when I reapply him, completely white, completely black. Very nice. We could use that, for example, in the opacity. If I change and just take one of these, plug that into opacity mask and make my material a masked material. Now I've created a way of scrolling my mesh into existence, just using a texture with black and white values and then making sure the edge pixels are all white. I can scroll that along using my UVs, and then I've got a way of creating an effect appearing. Again, very useful, very powerful if you start combining that with some nice masks, maybe some noises, get some really, really cool results. Next one, not such a useful effect, but included for the sake of completeness. What do I have going on here? Well, it's a circle, but if you look close to the texture, it's not a circle, it's just the quarter of a circle. So the other option in the tiling is for mirror. Hopefully that makes sense. So it takes that quarter circle, and then when it tiles, instead of being a repeat of the same thing, it's a mirror image of it. So if I go in here and change my tiling to, let's say, 4x3, you're seeing I'm getting 2 circles by 1.5 circles because I'm only tiling that quarter. Not that useful. Nice way to save some memory if you're only using a kind of a quarter of a shape and you want to mirror it 4 times. Included for the sake of completeness rather than because it's a useful thing, but might come up one time or another. Right. Last few things. Plug this guy into our emissive color. So what happens when we want to scale our texture, but we want a very specific texture? So if I plug this guy in, if I'm scaling our UVs, scaling your UVs by a number is the same as tiling. So if I call this tiling, that's a good word. There we are. If I use scaling tiling by 2, I'm taking this 1 by 1, multiplying by 2. Hopefully, if I frac this, it's good. You can see I'm getting that square repeated twice. So if I change the tiling as a parameter, I can now 3 times, 4 times. But if you notice closely, especially if I do kind of half a tile, 0.5, it's tiling from that 0 point. It's tiling from around that 1 square. I change that right down to 0.25. That's cool. Could be useful if it's a sort of a noisy tiling texture. It doesn't really matter that much. But let's say we've got something really specific on there, like a ring or something. We might want to zoom in to the center. So we can do that. So first thing we need to do, if I change this back to 1, have a look. So we know that this top corner, this top left, is 0, 0, and we're multiplying. So anything that multiplies by 0 stays the same. So that's the point of our pivot, isn't it? That's the point that we're going to be scaling around. And if I tile that to 2, you can see that top corner, that black, stays exactly the same. Well, all we need to do is move where that black point is. So first thing we do is subtract. if we subtract not 1 but 0.5, hopefully we have a look at this. That 0, 0 square has now, or that 0, 0 point in the square has now been moved to the center of what will be our sample later. Now when we multiply, nothing's happening in the middle, but see the red's got more red and the yellow's kind of coming in here. If I make this a really big number, hopefully we're going to get some better visual result here now. But see how quickly that gets to red? And again, what happens if I frack it? We're getting that tiling and that repeat, but it's tiling around that center point. Maybe that's fine. Maybe we can just plug that in, see how that works. Yeah, it's definitely tiling. Value 0.5. Oh, that's not right, is it? It's moved the offset that center point into here. So we need to add that 0.5 back again. So if we add that 0.5, we're just going to move that top square back to the top corner where we had, and hopefully, if I've done this correctly, see we've now kind of zoomed in on the center. So just by doing a little bit of maths, we all love maths, we understand what our UVs are doing. We can now have a setup quite simply, just by moving that pivot point first, or that scaling 0, 0. We can then get in and get something that scales nicely around the center. Let's do numbers that make sense. And if I do, 1.5, oh, I'm adding the wrong value, so that's not the right place. This needs to be 0.5. This is the value I should be playing with. Here we are. If I change that, 0.5, 1.5, you can see that square has stayed central, and we've just kind of zoomed out a little bit. So in actual fact, rather than calling this tightening, I'm going to call this one zoom. Nice little effect. Moving on. Here we have a noise. It's the same one we used earlier. And we're just plugging that into the UVs of a texture. Well, you can use any data you want to create your UVs. Here, that gradient has now been mapped by this black and white value to create this sort of marbly, swirly texture. It's pretty cool. We could take the red channel and append the blue channel maybe. Plug that in. How's that going to look? Oh, we're getting that kind of that noisy texture is coming through. Sometimes what you might use for your UVs, you could use world space, you could use world scale. Doesn't always have to be coming from a map. There's a few tutorials later on that get onto that. And then finally, last thing, objects don't always have one set of UVs, or at least they don't have to be made that way. We have a look. I've got a teapot in here. Everyone loves a teapot. We have a look at UV channel 0. This one's got a set of UVs laid out for some reason. We've also got UV channel 1. Quite often in environment art, this would be used for your light maps. That's probably what these are for. But there's nothing stopping us mapping different textures to different things of UVs. So let's just use that as an example. If I select this, bring my teapot in. If I create my texture for my UV map here, UV map. If I plug in this one here, text code 0, and connect to my emissive color, so that's using my first set of UVs. Nice, yeah, mapping my texture to my object, which is what we want. But see this text code here has got a 1 in it. So when you select or create one of your UVs, you can tell it which of your coordinate indices to use. And you can make these in Maya, you can add extra ones or Max or Houdini or whatever your choice of software is. But if I take this, create another one, and I plug in UV1, so you can see a completely different map, completely different unwrap of our object in different UV channels. Really powerful. Sometimes you might want to do a scrolling noise in the red channel, or red channel, a scrolling noise in UV channel 0, and then a mask in UV channel 1. And then by combining the two together, you see that. So there's no difference in the number of tiles. It's just the different UV sets in here that are giving us, there we are, giving us those different results. And like I say, if I could, let's try, well, yeah, you could do a mask in UV set 1. So let's do that quickly. So we're sort of at the end. So now I've got my texture aligned with UV set 1. And if I go back up to my mask here, I can choose this into opacity mask, and this is using UV 0. And now I'm getting one set of UVs and unwrap for the object, and one set of UVs and unwrap for the mask, which can be completely different, completely set aside. So, yeah, very powerful thing. Yeah, I hope that helps some people. Some nice little mathsy things. Do come in and have a play with your UVs. Try and understand what's going on. Fracs are really helpful node in that regard. You just want to say, well, what am I doing here? Okay, well, if I frac it out, quite often you get these really overblown colors and you don't really understand what's going on, but frac it back to even to 0 and 1, you can hopefully see that a lot better. And yeah, they're really powerful. You can do some really nice things, some really cool distortions and those kinds of stuff. So hope that helps. Hope people enjoyed that. If you have any questions, do have a shout. I think I've got one question here. How do you generate the UVs of a generated mesh? Well, that's probably a bigger question than this. So for objects such as, I don't know, an object you'd be modeling in Maya or Max or whatever, you'd have a set of UVs. You'd build them there, so you'd do an unwrap and you'd either project them from the side. If you were generating meshes on the fly in the engine, then you'd have to generate the UVs to do with that. There are, seeing as you've asked, some other ways you can do this. I think if I go for the bounding box, I believe, let me preview this. So this is taking the mask, the object's bounds and texturing it with data so that the bottom left corner, I believe, will be 0, 0, 0, and it's giving you values in red and green. So here we're not actually using any textures yet. We're just taking the data that belongs to the object. So where's the side of the object's bounding box? But it's red and green data, isn't it? If we append those together and then plug them into our UVs, should, with a little bit of luck, get the result. So here we're not actually using any of the UV map data that came from the object. It's all completely generated basically on the object bounding box. And if we plug in a different size object, we'll get a different result. So it's just taking that. You are going to get smearing on vertical things. No, go away. But hopefully with a nice sphere. So if this was a generated mesh, we could generate the UVs programmatically for the object as well. And you can also do things like world position. This is quite a nice one. So if I divide this by a large value, so the world position node gives us the data of the object in the world. So if I, for example, use my mesh teapot, every object obviously has its location. These are just values, it's just numbers. And we know that UVs are just numbers. So if I assign my material to that, there it is. Go back to my world position. The values here are very big. Remember we talked about UVs being 0 to 1, being quite sensitive. So we need to divide our big number by another big number. We'll call this UV scale maybe. So if I divide by 1024, something like that. Now I'm dealing with very small numbers again. And we're talking about UVs, aren't we? So we want to mask off red and green. What does that do? Let's have a look. So now, well, we've got something. Again, we're not using anything to do with the object or the UVs that get exported with the object. We're just projecting our texture down in 2 dimensions in world space. So wouldn't work for an animated object. If you were spawning a bunch of meshes and they were moving around, you'd want to use maybe the object bounds. But if I stick this on here, oh, there we are. This object, that texture is completely projected down in world space. So by understanding what those UVs are doing, we're able to just take any kind of data we want, using some input data from the world, in this case the world position, and just scale that around, and it will be seamless. So if we have 2 meshes, you can see how that's projecting in in world space, hopefully. You will get smearing, so it's not so bad on this texture because it's not got a huge amount of information in it. But if I do this, it starts to stretch and stretch and smear, and so useful for things like terrain or like a water plane, something like that. You can project it nicely. But yeah, I hope that answers your questions. Doesn't appear like we have any other questions at the moment, so I'm just going to say thank you very much. If you do have anything and you want to get in touch, you can email me here at Escape, or anyone here, and yeah, hope that was informative and helpful. Thanks so much.